Hey, what's going on, guys? Today we're going to talk about CFA Level 2, right? Level 2 Quants. So I'll try to cover everything in the next 20 minutes, right? I'll give you a lay of the land, what CFA Level 2 Quants is all about. Then, yeah, you can go into the nitty gritty of what things are. But I'm going to go and make you understand the big picture, right? So I will also go into in terms of what are the steps in terms of what are the steps in identifying a trend model, right? So big picture, what you're trying to see on here. So when you talk about CFA level 2 quants, we are going to try to predict the future, right? So step number one, if we want to go and predict the future, we need to have some kind of a model. Now, one model that we can go and create could be, could be a linear regression model, right? So the most common one is the one you see on here, right? Where X is an independent variable and Y is a dependent variable. So maybe if X goes up, Y goes up too. Maybe if X goes up, maybe Y goes down. So there's some kind of a relationship, but there's definitely not a cause. So just because X goes up doesn't mean that Y has to go up or go down. There's just some kind of relationship, but there is no, is not a cause. Like Y doesn't go up because of X, right? So there is relationship. So when I talk about relationship, we are talking about correlations, right? Correlations could be a positive, could be a negative, could be no correlation. Now, when you go and try to predict the future, so that's one kind of model you're going to predict the future, right? The other one you can go and use is in terms of a time series model, right? Which is you're going to regress up a particular security against its own past. So let's say if you want to go and predict an Apple stock, what we can do is we can go and regress it against the Apple stock against its own in the previous term, right? So this is kind of a time series model, right? Now when we talk about time series model, we are regressing a particular security at time t versus a different time series, right? Now when we talk about time series model, you can have a linear one, right? The linear time series. You can have exponential. Exponential is like this, or there could be seasonality, right? For example, in certain time frames, certain months, you might have something like a linear. It has a bump, goes back up, goes back, right? Or you can actually have, let's say, the other way around, which is, bumps lower after seasonal time series. It could be also, you're talking about two different. You might have a time series model, but they are in two different time frames. So maybe between the year 2000, right, and say 2008, these are like two different, very, very different time places or time series or time instances where things are very, very different versus what was the norm, right? So these are kind of four different time series models that you can potentially have. So that's step number one. Try to take a look at, are you going to use relationship basis to find the future? Or are you going to use the particular security itself, but in a different time series, using its past to predict the future, right? So those are two different models. And hence, that's the step number one. So once we have determined that, there is going to be, let's say we go with time series model, right? So when you try to talk about time series model, we got to take a look at the residuals. Now, what are residuals, right? Now, because we are regressing x at a particular time versus at a particular time, there is always going to be residuals. Now, we will go and do some kind of a testing for something called as a serial correlation, which means are the error terms correlated? Right, that's going to be a factor because If there is going to be a serial correlation, then we cannot really go and use the time series model. If there is no serial correlation, then that's great. Then we can actually go and use it. So to test the serial correlation, we have something called as a Durbin-Watson statistics or Durbin-Watson model, right? So Durbin-Watson is 2, 1 minus R. R is nothing but the correlation. So if its correlations is 0, then dW is going to be 2. Right? If R is not equal to 0, which means dW is not going to be equal to 2, hence there is going to be a serial correlation. Right? If there is a serial correlation, now if R is not equal to 0, dW is not equal to 2, right? Because I mean, this is really the equation that we are working with. So if R is not equal to 0, dW is not going to be equal to 2. Serial correlation exists. If serial correlation does exist, we cannot really go and use the model. Right? If we cannot use the model, then what are we going to do? We have to go and use something called as an autoregressive model. Right. So our autoregressive model is going to be based on, so I mean, the common ones that we talked about is, you know what, if you have, let's say, this is going to be the autoregressive model. This is so-called an AR1 model. Right? So we have an AR1 model. We got to go and take a look at, you know what, do some testing over here as well to see if we have an AR1 model. Is this really going to be a legit model that we're going to be using? Right now, how are we going to find out if this is a legit model we're going to be using? What we're going to be using is called Dickey Fuller Test. Right. So to test AR1 model, you're using a Dickey Fuller test. So what it really is let's take a look at the common equation. It's the minus 1 plus the error term, right? So what is the Dickey Fuller test? What we do is we introduce the first differences. Right. So when you talk about the Dickey Fuller test, when you're trying to do, we're going to be testing this very equation. In Dickey Fuller test, we consider this as B1 minus 1. So what Dickey Fuller test really tells us is if B1 is equal to 1, right? If B1 is equal to 1, then which means this value which you consider as G is going to be equal to 0. If G is equal to 0, it means there is a unit root. Because I mean, if G is equal to 0, there is going to be a unit root. If G is not equal to 0, there is no unit root, and hence you can actually use, it does not have a unit root, which means the series model that we have is actually stationary. Now, what is really stationary? What I'm talking about is stationary, right? So when you talk about models, right, there's different type of models that we can have. Right. What you're trying to do is you're trying to convert these particular models. Can you use this to predict the future? Probably not. Can you use this to predict the future? Probably not. Can you use this? Probably not, right? So what you're trying to do is you're trying to convert this model into this. This is what you're trying to do, because now we have a mean, and you know what, at any particular time, if you can convert these models, these type of models, into this model, then if at any particular time, if there is a value over here, we can go and predict the future. If there's a value over here, we can go and predict the future. So there's kind of a reversion to the mean, right? So that's why for any kind of models, we try to go and take a look at if we can actually convert a particular model into a covariance stationary model, and that's what it really is, a covariance stationary. Okay, so now that we talk about in terms of the covariance stationary, now what if, you know what, the AR1 model that we have is not a covariance stationary? Then we're going to use an AR2 model, right? I mean, if it's if the AR1 model doesn't work, why don't we use the AR2 model? Now, when you take a look at the AR2 model, right? So let's say we go on with AR2 model, we got to do the same thing again. Check if there is serial correlation in the models. If there is no serial correlation, right, which means the error terms are not correlated, then it's great. If there is serial correlation, then you know what, you cannot really go and use this model. That's what it really is. So we're going to do some testing to see if there is going to be serial correlation or not. So once we have identified whether it's an AR1 model, AR2 model, whatever the model that you come up with, and do the testing, and whichever one is a valid one, what the next thing that you want to do is check for seasonality. Right. So when I talk about seasonality, different time series models, for example, you know what, let's say between September and December usually is really great month for retails, right? That's when all the Christmas shopping and all the other fun stuff is happening. So you know what, maybe, you know what, you have something like this, right? Right. So in every September to December timeframes, you see these spikes, right? Now, if there is some kind of seasonality, we've got to take a look at, is it going to be does it happen every 4 months, every 12 months, or whatever it is, right? If it's every 4 months, then we're going to introduce the term, whatever the month is. If it's a quarter, or we're going to introduce the terms, we just got to add whatever the seasonality is, we add the particular month for that particular seasonality, right? So once we have gone and corrected the seasonality, what are we going to do? Right. Once you check the seasonality, what you're going to do is, in terms of trying to find out if there is some kind of, now that once again, what you got to go and do as some kind of testing is in terms of finding ARC1 models, right? Also called the autoregressive conditional heteroskedasticity, right? So we're going to go and test once again the error terms. One of the ways that we really do is we do the squared residuals from the time series, and we go and actually regress it against its own. So we're going to do some kind of regression on here. Best case scenario is when you do some kind of the testing on here, the square of the lag residuals is actually is not a serial correlation. Then you know what, that's great. If there is kind of if the coefficient does not differ significantly from 0, there is no heteroskedasticity, hence there is no ARC model. Hence you can actually go and use a particular variable. Now, once you're going to find out that you know what, there is no autoregressive conditional heteroskedasticity, the final step is going to be what? So you have figured out, you know what, there is no error terms, whatever you have, there is no, you have already done the testing for seasonality, you have done the testing for seasonality, you have done the testing for autoregressive conditional heteroskedasticity. What you're going to do is, in terms of, you came up with a particular model, now you have to prove how good this model is, right? I mean, because there was some data, right, that you was there, and using data of a particular time, you created a model. Now, why are we doing all this fun stuff? We're doing all this fun stuff to try to go and predict the future. If you can go and predict the future, so if we can use this model and go and predict this, or we can go and predict this, or predict this, how good is this model that you have can predict the future? The better it is, the better it can predict, the better the model is, right? So, I mean, if you can use this model and predict the future, then you have a really, really good time series model. If whatever model that you have, if it's not able to predict any data outside of the series that you're using, then hey, you know what, the model that you have is really no good. So maybe you got to go back to the drawing board and take a look at if the model actually makes sense, right? So that's pretty much in a nutshell of what you're doing in the CFA Level 2 quants, right? If you have any more ideas, do let me know in the comments. How do you like the video? Give me some comments. If you do like the video, do like and subscribe. Going to keep me more motivated to make more and more video for you guys to help you understand the CFA Level 2 program. Have a good one.